Great. Welcome, everybody. Folks are starting to join in, so I really appreciate you taking some time out of your day to join us. This is our monthly Ask Mayfield Anything series, and my name is Ryan Mayfield, founder of Mayfield Renewables. And as we're getting going today, I'm really excited to bring on the folks from AVO. We'll get introductions here in just a minute. As people are joining in, what we like to do with this webinar series is we're hoping to make this as interactive as possible for everybody. So as we're going along, highly encourage you to send in your questions. I ask you to send those in the question and answer section of the Zoom. So there on your screen, you see two sections. One is Q&A, or questions and answer. That's where we can track the questions a lot easier. So if you can put those in there, that's best. If you put it in chat, there's a high likelihood it's going to get missed. So just put everything in the Q&A. We try and go through these and make sure we're answering questions, answering those in real time as best we possibly can. So feel free to send those in and really enjoy the interaction there. So thank you very much again for joining us. So as I mentioned, my name is Ryan Mayfield, and I'm excited to share this presentation, share this information that we have with you. I have Johnny Mizer and Greg Richmond, both from AVO Training Institute, and I'll let them introduce themselves, kind of give you a background on who they are. But I'm really excited about this. This has been a course that we've been working on, or courses, I should say. There's 3 courses we've been working on for a fair amount of time with AVO. So we put these together. We built these together as a joint product, and so having AVO on board to help deliver these courses and spread the word as they're getting into renewables was a great thing for us. So Johnny, you're the training specialist at AVO. You and I, we met in Dallas. I got to do a presentation together. So will you tell the folks a little bit about who you are, kind of your background on in the training side?
Sure, Ryan. Glad to be here. My name is Johnny Mizer. I'm a training specialist, like Ryan said, at AVO Training. I especially teach code and safety, and I've got about 27 years experience in the electrical industry, most of it heavy industrial. So I've only been teaching a short time, but I look forward to teaching the code class coming up, and I believe we have one in February and we have another in March.
Yeah, that's a great point. So we have some dates and some ways that we'll get for you all to look at the AVO courses, and so yeah, at the very end we have those dates for you all to put on your calendars. So we also have Greg Richmond with us, Director of Training Operations. So Greg, will you give us both a little bit about you, AVO, kind of what the where you're going as a company with respect to renewables especially?
Okay, good. So thank you, Ryan, for the introduction. And I am Greg Richmond. I'm the Director of Training Operations for the Institute here. I want to make sure that everyone knows that Johnny Mizer is one of our top code instructors. He specializes in code. He's got a master's electrician license, and he's also specializing in training off his work time to focus on renewables energy. So I want to make sure that everyone knows that with AVO Training Institute that we do have a strong core of instructors that average 20 to 25 years of experience in the field. So when we hire our instructors, it's a very strong, scrutinized process to make sure that the skill set that they're hired for is exactly what they're going to be placed. So making sure that these instructors are very knowledgeable and have a strong background in where they're at and where they come from is extremely critical. We've been in the business of training for 60 plus years. So that says a lot for this company with its retainability. That means that this company is strong. Its reputation supersedes itself. And that's not only, I'm not just saying that because I work for this company, but it's the absolute truth. In my experience with using training companies as to further education with employees, AVO was the number one choice in the past, and it'll always be the number one choice in the future. So what we do as far as training is concerned is we specialize in maintenance and safety. So maintenance and safety, we follow industry standards, the NFPA standards. We follow NETA standards. We follow IEEE and ANSI and ASTM standards. We are also an ISAT accredited company, which means that our training processes are audited. We're not just a backdoor company that shows up and pulls equipment out of their trunk and fold out laminated papers. We have processes and procedures in place to make sure that our company thrives on success when it comes to ensuring that the right information is disseminated correctly. We offer three main types of curriculum. We offer a virtual platform, three types of platform. We also offer a virtual platform, which is what we're doing today with the virtual webinar. Of course, we teach virtual classes, safety classes, of course, utility, industrial facilities, 70Es is what our top courses are out there in the market. And we also offer open enrollment courses. We have 3 sites available right now, 4 including Dallas, which is our headquarters. And so they're located in California, Cleveland, and Carrollton, Georgia. We're opening up a new site in the near future in Southern California and a new site in upper Eastern Seaboard area. So look for those sites to come about on our website. Also, we specialize in on-site courses, which means that we come to your location, we come to your company, train your employees on equipment that's located in your area of operations, whether it be in a substation, an MCC electrical room, using your equipment. So we build custom courses as well. So keep that in mind if you have an idea of something that you may want specialized training in, a particular type of medium voltage breaker, maintenance and safety when it comes to transformers, then feel free to reach out to us. Poke around at our website, www.avotraining.com. Feel free to reach out to me at any point in time. We've got a crew of account executives that are skilled in specializing and finding out exactly what the client wants and specifying training to meet their needs. So a little bit about us again. We like I said, we focus on maintenance and safety, and that's where we're at. So I'm excited about this. This is certainly something that's new to AVO with the renewable side of the house. It's certainly not new out there in the field, but Ryan Mayfield and his team are exceptional, and we look forward to seeing where this venture goes and how this relationship grows. So thank you, Ryan.
Awesome. Thank you, Greg. Appreciate that. No, and I learned a number of things there. I didn't realize where you guys were adding your trainings. So that's great. I highly encourage folks to go take a look at their website, at the AVO website. I got to go to, as I mentioned, to the Dallas facility. It's very impressive down there. So great stuff what they've got going on, and yeah, look forward to doing more with you all. So real quick on Mayfield Renewables, just wanted to let you know, for those of you who maybe don't know us, we are a technical consultancy. We do system design and engineering for solar and solar plus storage projects. We do education and training, very similar to what we're doing here. We'll be at the NABCEP conference, actually delivering the full, the 6-hour NEC course. So what you're going to get a little preview of today is going to be what's delivered at the NABCEP conference. We also have a storage class specific at the NABCEP conference and things like that. So we like to do a lot of that kind of stuff as well. And then we are also doing a lot of technical consulting and microgrid support for folks. So if you have anything in these areas that we could potentially help out with, feel free to reach out. Happy to talk with folks more about that. So with that, we will jump in and go through the courses. So what we did early 2022 through mid 2022, so last year, Mayfield Renewables and AVO, we partnered up and put together these courses. So we have 3 courses, and at the very end, again, we'll show you the dates and everything, how you can take these. But there's 3 courses. One is focused on National Electrical Code, specific to solar. The solar, so 690 and 705, very heavily focused on that. We also have a safety course and an energy storage course. So there's kind of a way to round out the topics. And so today we wanted to take some time and just show you, go through some of the high level topics, some of the, got to pick and choose, if you will, from the each of those, and just talk about those different subjects and give you an idea of what these courses look like. So we'll do that. And so the first one we're going to talk about is the NEC, so solar and the NEC. Real quick, the thing I wanted to note is you'll see that in the title, this is all based off of the 2020 NEC. So the references, we have specific code sections that are called out, things like that, but those are all referencing back to the 2020 NEC. And then, of course, we have, as of, we're in January 2023 as we record this. And so the latest code version is out. So in this class, as much as we can, and in the full classes, we would, we'll talk about what is in the 23 code. How does it differ? What things should you change, or not that you should change, but what has changed, and just be able to look forward into that. And so I know not a lot of jurisdictions are in 23 yet, but nonetheless, there's always good clarifications in the newer code sections. And so Johnny and I were talking about that as we were prepping for this. And so we will, be doing that, or we'll be bringing those changes up as we go along. So I always like to start, well, I start even earlier than this with our code class. We talk about some of the first chapters, and Johnny, this is one of the areas where I know Johnny's really, really strong. In the conversations we've had, you have your general requirements, chapters 1 through 4, and those still apply to our PV systems. And so in our classes, like to start off with some of that pre-material, if you will, or that core fundamental material. But for this class, for this presentation, we're jumping straight into 690. And as it relates to setting the stage, if you will, there are these interactive systems, there are these figures that were added. They were actually added in 2017. They were kept in 2020, and then they were changed in 2023. And so here we've already, we're seeing some of those changes or talking about them. But even with that, these being changed, these are still useful for you to look at and to understand. And this really helps set the stage when we're talking about PV systems and how they interact with maybe other systems. And so this is a really simple diagram. This was modeled right after the figure B, the 690.1 figure B interactive system. So if you go look at your code book, you'll see something that this was based off of. Just we tried to make it a little bit more aesthetically pleasing. And we're just showing a very simple system where we have a PV array going to an interactive inverter, and that interactive inverter is getting connected to a utility source. And one of the big things I like to point out with this one, one of the things I'm trying to focus in on or set the stage for again is that PV system disconnect. So we're going to actually, in this today, we'll talk a little bit about PV or system disconnecting means, but the key here is understanding where does the PV system end, where do other systems start? And I'll show you another image here in a second, kind of adds to that and makes it a little bit more complex. It kind of helps delineate what those are. But this is one of the areas in the classes that we want to talk about is, showing where the systems start and stop, how to apply different code sections, and then how to navigate the different components within the system. So this is the other image. So there's actually 5 different images, and we go through all of them in the class. But this is another one. Just wanted to relatively quickly show it to the group. And so this is an AC coupled multi-mode system. Don't really have the time space right here to get into what all that means. So if you're unfamiliar with that, we have other resources and get into it very deeply into the class when we have extra time. But what I like to point out here, again, you may notice that top part, that top line looks a heck of a lot like that last slide that we just showed you, where we have a PV array, we have an interactive inverter, and we have a PV system disconnect. But in this case, this would be a system where energy storage is involved. We have a multi-mode inverter. We have a panel that is being backed up. So this might be a residential application where you want to back up some loads in the house. And then we have other disconnects. We have an interactive system disconnect. We have an energy storage disconnect. So the big thing I always like to try and do, again, setting the stage for applying the rest of 690, and then when we get into other code sections, is where does that PV system start and stop? We label that PV system disconnect. And so the idea here is that 690 is going to apply to the PV system, and the PV system stops at that PV system disconnect. So historically, prior to, I think it was 2014 and earlier, there was a lot of references to energy storage in PV systems. And we got clarification in 2017 that energy storage is not part of the PV system. And so the idea here being that what components are required to convert the solar energy to electric energy, and that defines what the PV system is. So if you can imagine, take away that PV system, take away the PV array, take away the interactive inverter, take away the PV system disconnect, that's a viable system that could operate just fine. It doesn't need the PV system to operate. So that's one of those things to think about is, what is required for the system to operate, and to help delineate where the PV system is and is not. I don't know, Johnny, if you had any extra things that you wanted to say on that.
No, you really kind of you broke it down pretty good. The PV system disconnect, I know we'll get into it further a little bit down in a couple of slides. But I was just going to mention that that disconnect, it has to be within sight or accessible is what they call it. And as far as these backup load panels, I just wanted to mention that there is other ways of wiring it where you don't have a backup load panel, because if you use this in a residential application, for an example, a lot of people, it's really hard to separate the loads, but not really getting into that, just knowing that we can wire that up a little bit different and still make it work and be safe for the utility grid. Yeah,
that's a great point. And so we're also, we're starting to see, and I see, Eric, you have a question. I'll see if I can address it here. We're getting these smart panels now, so we have the ability to tie these systems in. We don't have to necessarily pull out backup load panels like we maybe needed to do before, or it's not quite as difficult anymore. So we're seeing big changes coming to, or the industry is changing rapidly, and so we're seeing ways of integrating these systems a little easier into existing systems. So see, we have a few questions already, so I'm going to try and get some of these. So thank you all for sending them in. Question was if the PV+ESS course is adapted to the IEC standard. We talk about some of the other standards, not IEC so much when it comes to the safety and the storage. This one especially is really geared towards the NEC, and so we don't get a ton into the IEC. Question came in. Yep, the slides will be provided. We'll have a recording of this, so we'll look for your email that you registered with. We'll be sending all that out to that. Can we please see all the questions? I don't know how to make that happen in real time, so I'll try and make that happen for next time. On the AC coupled diagram, if we added a microgrid generator for power heating, would we treat as a separate system? So adding a generator into a system like this is very common, I would say. And it would be it really comes down to how everything's integrated. It would be, it's, you're still going to fall under generator rules. You're going to have to follow all those parts of the code. And so that would definitely come into play. And then it would just be a matter of, where does it tie in? How does it interact with the system? If you are on the line side versus load side of the utility service, transfer switches, all that kind of stuff. So it gets relatively complex, relatively quick. And so Eric had a question. So I'm going to read this out just because it's a little bit long here. So hybrid inverters are moving towards integrating solar PV, stationary storage, and bidirectional vehicle charging and backup power with smart electric panels and the utility. Can you discuss how complete house energy storage and EV differ from your AC coupled multi-mode system, and what standards the system would need to communicate with the utility grid for grid support, virtual power plant functionality? And then you mentioned IEEE 1547 and IEEE 2030.5. I can't say I can speak to 2030.5, 1547 for sure. So I think this gets into what we were just talking about, what I was just talking about with the smart panels. And we're actually going to have, there's some references into 705 later on. 705.13 talks about controls. So we'll get into that a little bit. Those would definitely come into play. Those code standards that you mentioned, 1741, just our standard UL listings would be there as well. Okay. Awesome. So we'll move on. But again, these are exactly the kind of questions we like to see. And when we're doing our, code class, all day code classes, we have lots of time to go through these and be able to dive into these deeper. Another code section. So jumping away from the scope part of Article 690, jumping up ahead a little bit, getting into 690.8. And so this is circuit sizing and current. I wanted to talk about this one because it was new in 2020 and relatively big change in how we calculate circuit currents and how we apply our conductor sizing and our overcurrent protection, disconnect amines, all that to our PV system specifically. So in this section in 690.8A2, we have circuits that are connected to the input of electronic power converters. Electronic power converters they're not exclusively, but inverters are going to be one form of an electronic power converter, and that's going to be what most of us are doing day in and day out. And what this allowance gives us is the ability to have conductors that are connecting, in this case, the PV combiner to the inverter. We can have those conductors, as long as they are protected with overcurrent protection, we can size those based on what the inverter input circuit is going to accept. So the inverter, as many of you probably know, the inverter can only accept a certain amount of current on the input side from the array. The way that we are sizing our PV systems, the PV arrays anymore, we are oversizing the PV array compared to what the inverter can actually take in and convert from DC to AC. So this allowance lets us have this big, large PV array, but we don't have to size those conductors to what the potential output of the PV array is, but rather what the input current from the inverter is. So Johnny, I'm not sure if you've seen this one or seen, or talked with folks on this one, but this is one where you may see the PV array twice the size of what the inverter can actually handle. And historically, we would size our conductors based on the solar output, not the inverter input. And so that's where this big change has come in, and really being able to help size conductors down to, they're small, that results in smaller conductors. And we're not really seeing any safety concerns or any real energy loss just because the inverter was already inherently limited.
Sure. I mean, exactly. It makes perfect sense because, there's no reason to size it to the potential if your inverter can only draw 48 amps for an example, you know. You shouldn't have to size it any more than required. That, you know, on larger jobs, that save a lot of money as far as just the conductor size alone.
Right, exactly. And so we're seeing this getting implemented more and more on, and again, this code does not, with very few exceptions, I should say, code does not differentiate between residential, commercial, industrial, anything like that in terms of the requirements. And so this is something that applies across the board, but the reality is that you're only going to use it in large commercial systems. So it's could be something that you could utilize residentially, but it's probably not going to be. Cool. Another section that we spend a lot of time on, we have a number of slides, is rapid shutdown. And I know this is everybody's, this is a topic that, you know, has gotten a lot of airplay ever since rapid shutdown got introduced. Johnny and I have talked about this a fair amount in our preparations and just general discussions. So one of the things reason I wanted to bring it up here today was, again, kind of looking forward to the 2023. There were some changes from 2020 to 23. They're not huge changes. The biggest, well, there was a section in 2020. It's been there actually since 2017. But just recently we've been able to utilize our systems that are listed to UL 3741. And that's a UL listing that's actually mentioned in the informational note of 690.12. And it gives manufacturers of equipment options for controlling the conductors within the array boundary. So for those of you designing and installing systems now on commercial, especially commercial or residential rooftops, you know that really one of the most straightforward ways to meet the rapid shutdown requirement is to have a piece of power electronics, a module level power electronics at every module, or having at most 2 modules in parallel on the MLPE. 3741 gives us some options, and so we're not going to dive into all of those things today, but there are now systems that are out there that are 3741 listed that give us the ability to put 2 modules in series. I know that there's some microinverter manufacturers on their commercial products. You can take 2 modules, put them in series, and have a 3741 compliant system. So you're able to get a little bit higher voltage, still not huge. And then there's other systems, racking manufacturers that have gone through and gotten the 3741 listing, where you can actually have a 1,000-volt system installed. So if you had a rooftop like this, you could have a 1,000-volt system with their 3741 racking. If you install the inverter per the manufacturer's instructions, and you wouldn't need any module level power electronics in that system. So it's pretty new and exciting. And so that's why I wanted to bring up the rapid shutdown here. And so, you know, Johnny, I know we were talking about, you know, using microinverters and things like that. And so, that was, you know, one of the big changes, is being able to make our systems higher voltage than what they have been previously, and still be compliant with the code.
Right, exactly.
Whoops, sorry, I didn't go too far. Okay. Sorry, I was trying to scroll through questions and I went through ahead. So on this one, you know, Johnny, we talked about this earlier. So the disconnecting means, and so 690.13, 690.15, gets into the PV system disconnecting means for 13, talks about the equipment disconnecting means in 15. And so one of the things that, you know, we put out here, or we're showing here in the 2020 code, talking about, you know, the location, the PV system disconnect means. And so this is one of those areas. So it talks about PV disconnect means shall be installed in readily accessible location. And so that's one of the things, Johnny, that's actually early in the code. They talk about readily accessible locations. That's something, can you kind of help me expand on that? Kind of readily accessible, what does that and does that not mean when we're talking about that per code?
Readily accessible is where you can access it without getting on ladders. It has to be where you can walk up to it and literally turn it off without any obstruction, without the use of tools or
yeah. So it readily accessible is exactly that, right? You can get to it. You don't have to resort to, I think they talk about resorting to the use of ladders or moving equipment, things like that. And so, of course, always the fun thing when you get to any commercial, well, not any, most commercial applications, they have the floor taped off of do not store anything here, and you can't see it because they've stored so many racks and things in front of the electrical equipment. So that would, we need to keep those kinds of things readily accessible. The one thing that I like to talk about and point out is, code actually specifically calls out that, a key is not a tool. So you could have a disconnect behind a locked door and still be considered readily accessible. And the point here is that the person who needs ready access has the key, and so they can get into that room. And that's one of the big points.
Yeah, I'm glad you brought that up, Ryan. I didn't even think about that because a lot of times, that happens in offices, buildings, hospitals, things like that, because they don't want anyone to be able to walk in there and perhaps get hurt. So they can lock the door and still be considered readily accessible.
Right. Yeah. So, so it seems a little counterintuitive, and for a long time, that's how I viewed it. If it's behind a locked door, it's not really readily accessible, and I would have people tell me, no, it's fine, it's okay, it's readily accessible. And I forget which code cycle they put it in, if it was 14 or 17, but there is explicit language saying that you can have it behind a locked door, and the key is not considered a tool. So, so that's a good one to keep in mind. Just scrolling through the questions here real quick. So this is kind of a general question. So will the PV plus storage course primarily focus on residential, commercial, or both? I mentioned how code doesn't really discern between them. In the courses, we've more often than not, we've tried to gear it towards the commercial and the larger scale systems. Of course, there are some residential applications, but with the energy storage, for example, you'll see some of our examples that we have coming up. They are more geared towards the commercial, larger scale systems. That's just been a historic market for AVO training, and so that's kind of what we've geared these classes towards. I see a couple of questions that I'm going to save to the end because I think it would be good as we're kind of wrapping up and have Greg help us kind of talk about it a little bit. So again, PV disconnect means, so I just wanted to show that same slide or that same system with the PV system disconnect. And again, readily showing that our PV system disconnect, we need those at readily accessible disconnects.
And they did make some minor changes in that. Nothing to really elaborate on, but 69013 readily accessible. They changed a few things out, not really anything new, but those are the things that we discuss in a code class. When we have 2 days to go over code, it's a great time to take one of the classes because we're still in 2020, but I'm also exposing 2023 to the class. And we kind of cross-reference, go into detail a little bit about it, and it's interesting.
Yeah, definitely, and yeah. So being able to, again, I can hear myself kind of rushing through. I know how many more slides we have to show, so I'm not purposely trying to do that, but we definitely have a lot more time going through these as we're presenting the class. And then this is a system that we didn't talk about, but this would be a DC coupled system. So again, this is a different type of system that we do talk about in the class. Again, talking just about the disconnect means the location, being able to disconnect to that PV system. And then finally, a standalone system, same thing, where we are isolating that PV system from the rest of the array. And this is an interesting one while we're on it. I'll take a second just to talk about it, but we have that PV system disconnect. And this is a case where the PV system disconnect is actually on the DC side of the system, not the AC side. Very often we'll see the PV system on the AC side. And so again, this is a situation of what equipment is required to convert the solar energy to electric energy. And if you turn off those disconnects, can the system operate without the solar? And in this case, where you see the PV system disconnected, the answer is yes, you can disconnect that and the system would still operate. So the storage part, the charge controller, while they are part of, where the charge controller specifically, is going to be connected to the PV system, the energy storage is not required for the PV system. So that's an important distinction. Okay, jumping over to Article 250, and this is a little bit, so we use this as kind of this precursor when we're talking about Article 690, when we get into grounding and bonding portion of our class. And so this one, again, this is jumping back into general requirements. And so this is helping us just show that our PV systems, they're not, they are still subject to all of the general requirements in chapters 1 through 4. 250, Article 250 being one of probably the biggest ones, grounding and bonding. Johnny, I'm sure you've spent a lot of time in Article 250 and looking at that. And so this is just helping us when we start talking about grounding and bonding, like to use this slide and to help set the stage, start talking about, what is an equipment grounding conductor? How does that come into play in our system? What is a main bonding jumper? What is a grounding electrode conductor? So really, again, trying to take the time to make sure that we are understanding these terms, especially with grounding and bonding. The terms can quickly become jumbled and we can start mixing things up. We have grounding electrode conductors, we have grounding electrodes. And so just kind of taking a little bit of time and talking about those. So on this one, Johnny, what is it that you like to talk about? And, when we're talking about grounding and bonding?
Well, when we was looking at this earlier, the main key things to take out of this is you want a single grounding electrode, one point going to the ground. Sometimes in the past, they've driven ground rods, and what that for the solar systems, and they're trying to avoid that, and they don't want your main bonding jumper to be in any, they only want that to be in one place as well, and that's along with your grounding electrode conductor. Right.
Yeah, and that's one that we also in the class, I can the folks that are doing the systems, I can hear their or see them jumping ahead to our interconnection methods and supply side connections, which we'll talk about. We have a slide even here today to talk about. And so that's an important one, is main bonding jumper, where we're making those connections. And then like you and I were talking about, Johnny, of in previous code cycles, we had these requirements that the PV system had to have its own grounding electrode conductor. And that has gone away, and highly recommend that people do not do that. It's an optional part of code now, but it's not a required part. And so definitely encourage people to not do that, just because it adds issues that don't exist otherwise. I would say. So speaking of that supply side connection, that's exactly where where my mind went when you were talking about that, Johnny. And so in the class, we go through 690, we go all the way through 690, and then we jump into 705. And I wanted to just bring up 705 here. It is a big topic, 705.11 specifically, as we're looking at it in the slide. Brand new section in 2020. And in 2023, as we were talking earlier, there's a number of changes. They even changed the name of the section. So you see some changes between those 2 years, not 2 cycles, I should say. Not surprising, since it was a brand new section in 2020, that there were some changes in 23. And so that's some of the stuff that we were talking about earlier. But we definitely don't have time to talk about it here today, but there are specific things that get into grounding and bonding with supply side connections. And the short answer that I've always been given, talking to people on the code making panel, talking to others that are heavily involved in all of this, when we're doing a connection like this, you treat it like it's a new service. And so we have a connection to the service side of the disconnecting means. So in this case, we're on the supply side of the service disconnecting means for that main service panel. And so as we would if this were a fire pump or some other system that we could connect to the supply side of that disconnecting means, we would treat it as a service with the grounding and bonding. So this gets into what you were just talking about, Johnny, and we dive deep into this in the class. Bonding the neutral to ground, how that's done effectively, and all those kinds of things.
Yes, absolutely.
Yeah. So we also get into 705.12. I just wanted to show this 705.11 for you all.
Well, keep in mind 705.11. I think you did mention it though. It had a lot of changes in it.
Right.
It's basically, it was new in 2020, and it's new again in 2023, basically. So, I mean, for the most part, they've made a lot of changes. But again, those are just things that we don't have time to elaborate on, but in the class we do. So that's kind of what we put our focus on in areas like that.
Yeah. So so Eric, you just made a comment of about arc fault and ground fault detection. We definitely get into all that. Again, we're trying to take multiple days of classes and condense it into an hour webinar. So kind of just did some picking and choosing, but we definitely go through the entire article 690, 705, and we touch on other articles along the way, especially those that are very pertinent. So thank you for that. But yeah, we definitely spend a lot of time on other sections. 705.13 is power control systems. This one was introduced also in 2020, got changed in 2023. So there's a lot going on here. And I know that this diagram has a lot going on. Long and the short of it is we have the ability, that power control system, you see it's kind of that magic box there at the top center of this image. We have the ability to use systems, power control systems, to regulate where the power is flowing. And so we can use it to make sure that we aren't backfeeding too much power to that main service panel. So we can actually have systems, PV systems, energy storage systems. We can take these multiple types of systems, put them together, and using a power control system to do our interconnection. So we're starting to see more of these. We're starting to see these, as listed systems. So this is something to, we'll spend more and more time on in the class. But this is just another one of those brand new things in the 2020 code and worth spending time on talking about as we're going through to understand how do we actually apply these in the field and get them to meet code. Okay. So that was, again, just a high level, just some very, very key sections of the NEC. And we also have 2 other classes. So we wanted to give you some preview on that. So solar systems and safety, again, focusing in on very much on the larger scale systems as the kind of the focus, but there's definitely applicability here across the board. So there's, nothing that is not applicable for smaller residential scale or small commercial systems. So one of the things that we do is we go through our systems, and so we break it down into multiple sections, and one of the sections is identifying the hazards. And so we go through and we're just helping folks that maybe are coming onto a larger system. Maybe they haven't seen a lot of the larger arrays, or quite familiar with all of the sources of hazards. And so just wanted to spend time on that. And so in this case, we're showing, combiner boxes. This is an inverter that has a combiner box built into it. And so wanting to talk to people, or wanting to show kind of what some of those hazards are, how to take readings on those systems so that they get a better sense of that. And so, we get into what the typical hazards are. We talk about doing reverse polarity, kind of how that might look, what that might look like when you're using a digital multimeter. If you're using your clamp meter, how that might look. And so trying to really help people work safely in the system. And that's one of AVO's, really big fundamental things is, safety. So of course, we all want people to be, coming home at the end of the day. We want to make sure that we're operating these systems as safe as possible. So trying to work with folks to understand what those hazards are. Again, identifying hazards, just kind of helping people understand where some of those are going to appear. You definitely have your multiple power sources, transfer switches when we're talking about incorporating generators and things like that, backup power, and then first responder equipment. So kind of, we go through all of those and make sure that people are feeling comfortable with that. Johnny, I know I'm kind of running through. We have a whole other section to get through. Are there things that you wanted to say about those sections?
No, you're fine, Ryan. The only input I would have is when it comes to the courses. All of our courses, I don't want to say they're based on safety, but we include safety in every one of them. Even with this course, we would include parts of the 70E, and just to get people familiar with it, if nothing else. And of course, introducing them to the right tools, right equipment, right PPE, the correct PPE, things of that nature, just to make sure when they walk away, then they not only they can work safer.
Right. Yeah, so that's great. I appreciate that. And so as part of the safety class specifically, we include other references, other resources for people to go to reference. So you talk about 70E and some of the other sections, and that's where somebody asked earlier about the IEC standard. So we kind of point to where some of those are, so people can be operating these safer. And then the other thing that occurred to me as you were saying that, Johnny, was that these courses are not just, you're not just sitting there and looking at PowerPoints. We put together, AVO did a great job putting together handouts, or a booklet that goes with the courses. And so it's something that you have what you're looking at up on the screen and the bullet points, but then you have a little bit more deeper dive into it. And so it's a great way to be able to follow along as you're taking the courses, taking your notes, things like that. And so there's more to it than just sitting there and looking at the PowerPoint all day long. So as part of the safety course, we also like to get into a little bit on the some of the tools. So here we're showing multimeter, and how we're going to use those, where we're going to use them, what we're trying to get out of them, and how to operate those safely as well. And so trying to get people familiar with what these requirements are, and so that we can operate our system safely. Whoops. And then one of the other big tests, and so this is one that we probably stop and talk a lot about, is the insulation resistance testing. A lot of people refer to that as, doing the Megger test. Megger is a brand name, and should point out AVO is connected with Megger. And so there's definitely a lot of focus on, talking about how do we do insulation resistance testing properly? How do we, where do we do it? How do we isolate parts of the system, and what is it that we're trying to accomplish with this? And so this is a big part of the class, talking about the tools, how to apply the tools properly, and be able to safely operate those tools. I'm sure you've done your fair share of IRT testing, Johnny.
Yes, sir. Over the years I have, and we always refer to it as Megger. And but yeah, it's actually an insulation resistance test. We've done that quite often, and it's an important test. So
right. And so for those of you that maybe not familiar, the 30,000-foot view is you're using an insulation resistance tester to test the insulation and make sure that it is still keeping the electrons where they're supposed to be, which is on the copper or on the aluminum itself, not leaking out and putting people at potential for shock hazard or ground faults, fire hazards, all that kind of stuff. So it's an important test, and it's getting used more and more in PV systems. It's a pretty standard thing in what I call traditional electrical world, but we're seeing it more and more in our PV systems. And so we spend some time talking about it. All right, I wanted to make sure that we had at least a couple minutes to talk about energy storage. This is one of the, all of these classes I'm super excited about. The energy storage was an incredible thing that we put together, pretty much brand new information. There's a lot going on in the energy storage world. And so just wanted to, again, giving folks just kind of that big picture of what the class talks about. But we go through, we have it broken down, I believe it's 6 sections. And so, early on in the class, we're talking about applications for energy storage. And one of the biggest ones that we are seeing, we personally at Mayfield, and I think the industry as a whole, we are seeing a lot of microgrid applications. And so we talk about that. We spend some time talking about, what is a microgrid? What isn't a microgrid? How does it all work together? What components do you need? And where does the energy storage fit into this? Because the energy storage is one part of this, but microgrids are referenced in the NEC in 706. And so we want to talk about that, want to cover that, and kind of get people feeling comfortable around what are the components of our energy storage systems. So not just microgrids, but we'll talk about AC coupled systems, DC coupled systems. We talk about systems that are providing backup power, those that are providing just demand response type applications. And so we get into the applications aspect of this as well. So folks that are installing the systems, designing and installing the systems, get a better sense of how they're being applied and what they're being used for, what those use cases are, and make sure people are comfortable with that. One of the other things that we do is we talk about specific technologies that are being commercially used in our solar plus storage systems, and sometimes not even there's not even solar involved. Maybe sometimes it's just a storage system. But we get into talking about the different technologies, the different, why you might choose a lithium iron phosphate over a lithium a cobalt battery, and so we get into those and talk about, we don't take a super deep dive, I would say, but kind of giving people a sense of, why we would choose these systems, or, how they work, how they interact, and then the pros and the cons of some of these different technologies. So we've kind of built these images out to help give a good visual representation of, what the systems are, what the energy storage is that's being used. And then talking about the safety aspect of it as well. As Johnny mentioned, safety is core to everything that AVO is doing. And so safety is going to get wrapped up into all of these classes, not just the specific ones. And so, making sure people understand these technologies, what the safety implications are, what they, where they may be different from some of their competitors. And then we also dive into, so we had a whole, we had our whole class on NEC, but we also take an opportunity in the energy storage class to talk about National Electrical Code here as well. And the NEC class was really focused in on 690 and 705. We really dive into what are the requirements of 706. Article 706 is the energy storage section or article. So we take this class, we use that opportunity to do that as well. And then things like this, kind of helping show the students, here's a PV system, here's an ESS system, here's where that delineation is. Yes, they're both going to that AC interconnection panel, as this shows, but the energy storage system is under 706, PV systems under 690. So we have these different systems, trying to help keep them separated and show you how that happens. And then 705 being the interconnection section. So we get into all of these sections. You can't get into absolutely everything, can't go through chapters 1 through 4 in the amount of time that we have, but definitely refer back to what those requirements are and help people get a sense of that.
And we do that in our class, Ryan. We chase rabbits sometimes, if you will. If it gives us the reference back to 230.43, then we go back through there, and then it gives you a reference to 310.10, and you just kind of chase a rabbit hole. What we do is we try to demonstrate a way or show people not how to use the code book.
Right.
Because once you learn how to use it and how it works together, it's a lot easier to understand.
It's a great point. Yep. And so being able to have your code book there and work with somebody who's that's one of the big advantages of being able to do that and work with us as we're going through and doing those classes. So it's great. Great to do that and be able to take the time for that. I wanted to point out that we also get into NFPA 855. This is the standard for stationary energy storage systems. So we have a lot of slides. We get in deep into 855, what those requirements are. For those of you that are for California, for example, if you're doing energy storage in California, NFPA 855 is directly referenced in the International Fire Code. So there's some direct links to these requirements. And so it's a good way of looking at this and understanding kind of where those requirements are coming from, what the requirements are, when you have what your storage capacity is, spacing that you have to have from your components and all those kinds of things is stuff that we go through in this class. And then finally, we get into some of the firefighting considerations. This is a huge thing with, unfortunately, we're seeing stories all too commonly anymore of, fires that are associated with energy storage systems. So making sure that we're installing these systems as safe as possible, keeping firefighters in mind with that, that's a definitely important thing. And so getting into the Annex C of the firefighting considerations, and if anything, walk away from the class, NFPA 855 talks about suppressing fires and how water is the preferred agent for suppressing lithium ion fires. And it really gets down to the cooling ability, the ability to take the heat away from those fires is really what that comes down to. So, but we dive into that much more. We talk about some of the kind of high profile systems that have had issues, kind of what happened and some lessons learned from those systems. All right, we're right at the top of the hour. So I really appreciate everybody joining in. And I just wanted to, we have some courses coming up. I wanted to give you an idea of, both Mayfield and AVO. We have, so Mayfield will be at the NABCEP conference. Love to see you if you're going to be there. And then AVO, Greg and Johnny, if you want to talk about those just real quick, I'll give you the floor on that.
Sure, of course. We have our first class in February. It's February 6th. And then we have our second class in March. It's March 6th. and we're going to go through the code, where it's a 2-day class on the code, and then we go through solar safety and of course batteries in ESS systems, and you know, go through all that. We spend a lot more time on it than we do here, like in an hour. It's really you give us a couple of days to go through it, and we all get a better understanding of it, and so I look forward to it.
Yeah, so it's great. So so the first ones will be, are those, I'm sorry, Johnny, in person, or are those going to be web-based classes for folks?
The first one's in person, the second one's web-based.
Okay, awesome. So yeah, highly encourage folks, you know, be able to, if you can get down to see our friends down in Dallas, that's a great place to go. They have a great facility. And so, yeah, that's awesome. And so then there's the link there where you can register for the courses, and we will get all of this out to folks. We'll have links for you in the follow-up so that you can directly look at those and hopefully register for the courses.
Right. Can I put a plug in real quick?
Absolutely.
Okay, good. So I wanted to make sure that everyone knows that those courses that Ryan and Johnny Mizer are talking about are always going to happen on the first full week of the month. So they'll be the first full week of the month. They'll start on a Monday, and they usually will end on a Wednesday. Every other week they will be in person. Keep in mind that that these courses are mobile, which means that we can take these courses to you and present these courses to your employees at your training site. So just kind of keep that in mind with the versatility. They're not just strictly limited to on-site location or open enrollment and at the Dallas site and open enrollment virtual. We have the ability to take these courses on the road as well. Every student that attends the courses will get copies of the course material and an excerpt of the National Electric Code as well with that too. So just kind of keep that in mind. And there was one other thing I was going to plug in there also. Oh, I know what it was. So moving forward with plans for this course, I think I mentioned earlier that AVO was a ISET approved company. Our training processes are approved and our procedures are agreed upon internally. So with that being said, our goal is to make this course a certification course. So we do offer certification courses, and moving forward, the solar renewables technician will be a certification course. So if you took all three of those courses, and certification will be granted through AVO Training Institute for those three courses. So that's kind of what the plan is moving forward, just to kind of keep that in mind.
Great, and that was actually one of the questions that I had put on hold to ask you, Greg. So the question came in was, any plans to add IRA certified apprentice programs for either the mechanical or electrical installation of utility scale PV projects? I haven't had a chance to look at the IRA certified apprentice programs. I'm not sure if you have, Greg, or if that's something that AVO would be looking at doing, but you know, there is some level of certification with the courses. Have you guys looked at that one at all?
So that's a good question. So I do plan to move forward with other avenues of the photovoltaic setup. So we will be working with Ryan Mayfield and his team moving forward. But really what this is going to be dependent on is what the need is. So if we see a need out there that's geared towards a particular area, then certainly we'll capitalize on it. Because if there's a need of one, there's most likely going to be a need of 10 or 15. So certainly keep that in mind. If you think that you'd like to see something specialized, remember that we do build specific courses for clients. So based on what our capabilities are, we may outsource that to a company like Ryan Mayfield, or with our technicians that we have in-house, we can build those courses here in AVO Training Institute by ourselves.
Great. One last one, and then I'm going to cut us off here. Are the classes eligible for NETA CTD credits? And that's not one that I'm familiar with, Greg. Do you know what the NETA CTD credits are?
I can answer that. So that's a good question. So we do offer continuing education units for advancements and for credits for your licensing and so forth. So that's what we offer is continuing education units. I'm not sure. I think it's 1.3 for CEUs for each one of these one-day courses. But I do know that for our 4.5-day courses, they're a little more than that, around 3.7, I think, or something. But NETA CTD, moving forward with industry standard leaders, of course, we are endorsed by Pearl as a certified or recognized by Pearl as a leader in the training industry. My goal is to move forward with NETA, to move forward with AVO being recognized in the training industry as well. So look for that to come in the future as far as specifically towards NETA credits.
Perfect. Okay. Well, there's a number of other questions, and I really apologize. This was one of the best in terms of getting questions, and I couldn't get to everybody. So I really appreciate the interaction and people doing that. Our contact information is up here. If we didn't get your question, feel free to reach out. And again, we will be getting all of this, the recording back over to you, the links and things like that for the courses. So Johnny and Greg, really appreciate your time. All of the attendees really appreciate you sticking around and listening in. So thank you very much, and hope to hear from you soon.
Thank you, Ryan.
Thank you, Ryan, and also thank you to all the attendees that showed up. Great showing, and thank you to Ryan Mayfield for allowing AVO to be a part of this webinar.
Awesome, our pleasure. Thank you so much.